Yeah, your geometry teacher was a jerk. So if I'm looking at this problem here, if I'm placing theta there, what trig function do I have to use in order to solve for that? Inverse cosine. Good. Now, when we're talking about inside the triangle here again, are we talking about radians or are we talking about degrees? Degrees. Where are the buttons on your calculator to make sure you're in degrees? Mode. Remember, guys, go back to your mode. Change it up. You're going to have to be responsible for making sure you understand when you're using what. A lot of times when you're looking to solve out the triangles, you're always going to be within degrees. This loads. Because remember when they're talking about radians, you're talking about it in terms of pi. Parts. Yeah, it's remember how we were getting stuff in radians and say it's like pi over 4? Well, that's 45 degrees. So it's kind of using the same way. If you do the decimal equivalent of pi over 4, that would match up. It's kind of what it's working through. Again, remember, you're going to hit mode, and just make sure degrees are highlighted. Okay? If it's not highlighted, you guys all know how to switch that, correct? All right. Again, what was it? What trig function?
Inverse cosine.
Inverse cosine. What'd you get for theta? What are you getting? Does that make sense? I'm going to take a stab and think that you're not in the right mode or you're pressing the wrong buttons. 56.3, you guys agree? Now, again, a lot of this stuff you guys have seen. What's going to be different now, well, here, let's try one more real quick. What trig function are you going to use? Sine. You use the inverse sine here. Yes, sir?
Why can't you just use
Are you trying to find the angle? Remember, whenever you're trying to find the angle, you have to use the inverse of it?
Yeah, that makes sense.
Yes, ma'am. If I'm trying to find the side, then I would use the button itself. But if I want to find the angle, I always use the inverse. Yeah, remember, inverse for the angle, regular for side. Okay? Inverse for the angle, regular for the side. It's a very common thing that people mess up. So you said it was sine? What'd you guys get?
34.85. 34.85.
Everybody agree? Again, this isn't anything you guys haven't done, but what the twist is going to be is the following. Trig equations. Trig equation, and this is the new stuff. Now, when you're working with the trig equation, it's asking you to figure out what theta is. What sine of theta is going to give you -1/4. But notice it gives you a little bit of a parameter. The parameter they're asking you to be is in which quadrant? Wants you to be in the third quadrant. Think about when you are solving for theta when you're working with sine. What quadrants are you working in when you're solving for theta with sine? Louder, I heard you say it. 1 and 4, good. 1 and 4 is where you're solving for your sine of theta. Now, if you're solving for sine in 1 and 4, and you find theta, how are you going to get the angle measure that's in third?
Reverse the answer you get from the question.
What do you mean by reverse?
Switch the signs
Switch the signs?
from positive to negative.
What did we call that? Moving things around. Not inverse. Remember how we found all the different the reference angles? Remember that? Vaguely. All right. Hit your button. Hit your button on here. Make sure you are in degree. What angle is going to give you a sine of negative quarter? What's theta?
45.
Inverse sine. I'm getting negative 14.48. Everybody agree? So if I'm getting negative 14.48, that puts me into which quadrant? Fourth quadrant. Now, if I'm fourth quadrant here with negative 14.48, do you remember how to figure out the angle measure in here to have the same reference? Very good. Remember how you bounce back and forth in between the quadrants depending on which quadrant you went into? Your reference angle into the third quadrant is when you add into 180 to bounce it away from the x-axis. If you had to go to second, you'd subtract it to come back up. So what would theta be in the third quadrant that has a sine of negative 1/4? You're bouncing into that third quadrant. You have to figure out how to have the same reference angle. What's
Where's
that?
that negative 14? Where did you get that from? Where did
The
that-
inverse sine?
Yeah, but what quadrant?
Fourth quadrant. The negative angle. Remember, sine is measured between first and fourth quadrant, so negative is going to come down. And when you're talking about sine, that means they're sharing which do they share, the x or the y coordinate?
The
Yeah.
sign?
Correct. So it just moves over. So we got to bounce it back up for that quadrant. Again, what we're looking at being able to do here, guys, is you're working with reference angles, bouncing into the correct quadrant that fits that mold, if you will. Okay. Excuse me. Let's try these two. I have the sine again. Sine of theta is negative 0.35. Notice it wants to go to the third quadrant. So if I'm going to hit the buttons the right way, I hit inverse sine of negative 0.35. Negative 20.49. Are you okay with that? Now, negative 20.49 drops you to the fourth quadrant. You want to be in the third quadrant, so what do you do again? Add it to 180. So what do you get? Now think about it. Is sine positive or negative in the third quadrant? Is sine positive or negative in the third quadrant?
Oh. It's negative.
It's negative. Try tangent. Try tangent, see what you come up with. What's theta that gives you a tangent of 2.4? 67.4? Now again, once you go to the third quadrant, what do you do? Bless you. Just add 180 to it. So what is that?
No, the first quadrant.
Think about it. You want to be the third quadrant. Isn't tangent positive in the third quadrant? This is a sine and cosine both negative. It's negative divided by negative. It is positive. That was the other thing that some of you guys messed up on that quiz.
That could have been positive, or that could have been 1/4.
I'm sorry, what was that?
So the 67.4 could be 1/4.
Yeah, but remember, tangent, when you first find tangent, it's also between 1 and 4. because that's how it's allowing to find the positive and negative on that. But it doesn't occur at pi over 2 or negative pi over 2. Remember it had that asymptote we were talking about? Because it's undefined. So tangent went 1 and 4, sine went 1 and 4. Cosine's the weird one, it goes 1 and 2.
Wait, cosine's the word?
Yeah, cosine goes 1 and 2. So since we're both negative in the third quadrant, that is why, again, tangent is positive. Hopefully this isn't so bad. Try a couple more, and then we'll, I think we'll discuss that quiz. Excuse me. We start this one up. We have, what is it? The cosine, so we have to do inverse cosine, 0.43. That gives me an angle measure of 64.53. And they want us to be in the fourth quadrant. So if this angle here, the reference angle here will be 64.53. To come back down here, in order to drop that down there, I take 360 and I subtract that. So in order to get down there, I would take 360 and subtract. Oh yeah, you can do that too. That would work. I'm just trying to, because remember when you were talking about, we don't want to bounce off those y-axis because that can become a bad habit. You could get, yeah, because if you add 270, you're getting the angle here. If you take, starting with 270, you add 64 coming up, you're not going to be in the right spot. Don't bounce off y. Don't bounce off y. The only time that would work is if it was like 45 degrees. So don't do that, all right? Remember, whenever we're working with reference angles, we're bouncing off x. So if you're going to go to the fourth quadrant, you're dropping down. If you're in the second quadrant, you're dropping up. You're going up. Third quadrant, you're dropping down. So you just have to remember which way your arrows were popping so you can go through like that. Okay? Same thing with sine. Inverse sine of 0.8. When I move that stuff around here, 5113. Or did I just write down that wrong? 53, excuse me. And then in order for us to be in the second quadrant, what am I going to do to bounce that into the second quadrant?
180 minus 6.
Good. Good. So was it 130, 126? 87?
I don't understand. You were talking about like
Gentlemen, question up here.
cosine is between 1 and 2, and sine and tangent are 1 and 4.
The rules for these things when you're solving these out is that when you do an inverse cosine, your inverse cosine is always going to be between 0 and 180. That's the value they're going to give you. When you do your inverse sine, the values they're going to give you are going to be between pi over 2 or 90 and negative 90. So it goes.
It's same thing for tangent.
And same thing for tangent. But at tangent, remember there's an asymptote here and here. Because it can't, when you're at tangent at 90, remember it's 0, 1. So it's 1 divided by 0, it's undefined.
Yeah.
So it's undefined at pi over 2 and negative pi over 2, but it's still parameters itself to
But
it.
it can't be those two.
Correct.
All right.
Yeah. Okay. That's where those things come from. And that's the values they're going to give you on the calculator when you do that. And then it's just a matter of bouncing it into the other quadrant.
All right.
Okay? Let's talk about the quiz then.
Can we do the first, the second?
We do the first, the second, the third.
I spent, yeah, I got one.
So let's see here. We have the secant of 40 pi over 3. So when you start working about secant of 40 pi over 3, you have to figure out what quadrant will that lie in. So 3 goes into 40 how many times? 13 and 1/3. So there's a couple of things you can do. You can tell right now what your reference angle is going to be, right? It's going to be pi over 3, but we just got to figure out what quadrant is that pi over 3 being placed. So as you spin it around, 2, 4, 6, 8, 10, 12. Everybody okay with that? 13 pi over 3. And you can just keep spinning around, And that's fine. That's what I normally do too. Okay? And that's how you get your reference there, guys. That's how you get your reference. So when you draw that one through, secant is the inverse of which function? Cosine. So secant's inverse cosine. Pi over 3 is dealing with which angle? We know it's a 30, 60, 90, correct? Okay. The 30, 60, 90, we know it's going to be inverse of cosine. What angle is pi over 3? 60. So when you draw your triangle, here's your 2 and there's your 1. 2 over 1, third quadrant, negative. A lot of you guys had 2, just forgot the negative. Oh, let's see. Cosecant. Cosecant, negative 20 pi over 3. Again, 3 goes into 20 how many times? 6 and 2/3. So we have negative 6 and 2/3 pi. So we go around 2, 4, 6.
Isn't it negative?
Yeah, I was spinning the right way. And then 2/3 brings us back here.
Can't cut over.
I'm sorry. Just visualize it's perfect. It's gonna be hard. Fine. I did it again. Sorry. Is that better? All right. What is your reference angle now? Pi over 3. Again, we're at pi. Because we've gone 2/3 pi, we are pi over 3 left to get back up here, so our reference is at pi over 3. We're inverse sine, so we are at, if I'm at pi over 3, I'm here again. So when you write that out, you're going to get 2 over root 3, which is 2 root 3 over 3, but I'm in the negative, so it's negative 2 root 3 over 3. Okay? It is not ridiculous, it's just math.
I know, I just, I know how to shut all of these, and I still got
I'm sorry. I didn't mean to, because I didn't think I would have said that, but I would have said, I would have said quantity to you, I would have done the same thing. It could have been worse. Tangent, 225. Right off the bat, you can tell right away what your reference angle is going to be. It's going to be a 45. Does everybody agree on that?
Yeah.
Why is it going to be a 45?
It has a 5.
It has a 5. It's very easy. Now, we also should remember whenever you have tangents of 45s, what are your ordered pairs? Ooh. The ordered pair for your triangle. When you're looking at your ordered pairs at 45 degrees, what is the x and the y value always? You're right, it's 1, 1, root 2. But if I'm looking at the actual ordered pair, 45 degrees, remember when we wrote it out in the triangle? Thank you. That's what I was looking for. It's root 2 over 2. It's the same value. The tangent of 225 is going to be the same thing. This is root 2 over 2 divided by root 2 over 2. It's 1. Now it's just a matter of figuring out what quadrant are you in for 225. What quadrant is 225? Third. Is tangent positive or negative? Answer is 1. And then sine of negative 9 pi over 4. Negative 9 pi over 4 spins you to which quadrant? Fourth again. Your reference angle is what? 45 again, so pi over 4. Sine of 45 is 1 over root 2, otherwise known as? So it's root 2 over 2. But in the fourth quadrant, what is it? Negative. Okay. And that's a lot of the big things that people were messing up, is they were forgetting where things are positive. Ladies and gentlemen, remember, yes. I'm sorry. I never screw up. Remember, guys, we talked about this stuff earlier. Use the idea of your ordered pairs. Use the idea of where x's and y's are positive and negative. They're both positive here. Negative and positive, negative, negative, and then positive, negative. Because your ordered pairs represent what trig functions? Which one's first?
Cosine.
Cosine. Which one comes first in the alphabet? Cosine and x. Dumb, but it works. Cosine's positive, sine's negative. Divide them out, you get tangent is going to be cosine's negative, sine's positive. Divide them out, tangent will be, and so on and so forth. You guys all know how to place points on a coordinate grid. The only thing that's changing, instead of saying it's x and y, we're saying it's cosine, sine. And that's how these things just shift themselves around. You're doing just fine. You can come up with the triangle. It's just the placing of which quadrant is messing up a lot of you guys. Use the idea that you know how to place ordered pairs all day long. That's not a difficult skill for you guys. You can do that with your eyes closed. What I want you to be able to do is make sure that you know which one they're dropping into. Okay? Questions, any others on that? Now, when we get to the test thing on Thursday, yes, there will be calculator, there will be non-calculator. You will have questions like this again, as well as what you guys did last night for homework. The inverse sine of root 2 over 2. But that one is the same basic process. You're trying to figure out which angle is giving you that. You know where your root 2's over 2's. You know that's going to be a 45. You know that if it's a root 3's, you know how to work it up with the two triangles. It's just a matter of knowing how to place them within the quadrants themselves. The only other non-calculator part, those would be, I think that's about all we would have for non-calculator. The calculator part is going to be kind of what we've just done today, with bouncing into those two little quadrants. And I got a couple of word problems out of this stuff for you guys to look at tonight as well. Very straightforward, okay? So tonight, what I want you to do, starting in the next section, or it's the same section, it's just the next page. You've already, excuse me. Let's do, I'm not gonna waste our time with those. So this is what, 796. I'd like you to start at number 44. And I'd like you to go through 56.
794, 56.
Please. Okay? Tomorrow we'll go over this again. There is one other part of calculator stuff that we will look at in section 13.3. It's called projectile motion. It's all calculator formula. It's very straightforward. Now, that'll finish us up. We'll review it all on Wednesday. Test it on Thursday. Does that sound good?
Are you going to make one of those ones that you just
Yeah, I can make one up. Yeah, I can make one up. Yeah.